So here, okay, we've discussed again. In this case, we can find the information by sketching the condition. Sketching condition will make this much more understandable. Okay. For the first one, for the Isabella, they're going to increase by A. So it's going to be for 5 seconds. If you know it is A, this is going to be 5.5 because A is 1.5, right? Then as we go for 10 seconds, the total is going to be 55 meter. Okay, and after that, we are going to decelerate, okay, for 5 seconds. So this one here, 5.5 times 5 over 2, okay, that is the area for this part and that part. Okay, for Maria, this is for Isabella. So it's going to be 5.5, 5.5. For Isabella, we have the condition here, 27.5 meter already given here. Then the speed is 5, constant for 10 seconds, means it is 50 meter. And after that, decelerate for 5 seconds until 0, 5 seconds. So 5 times 5 is going to be 12.5. So we can calculate the total distance for Isabella and for Maria for now. Maria is 90 and Isabella is going to be total 82.5. Okay, is it clear enough?
Yes.
Okay, let's go to the next question then. Find the value of A for which the two cyclists travel the same distance. Okay. In the previous question here, we know that the question that Isabella is going to be 75A and Maria is 90 meter. So if they're the same here, 75A is 90, A is 1.2. Okay.
Oh, it's only like that for B?
Yeah, that's why it's only 2 marks.
Okay, then fair enough.
The previous one here, this is going to be 5A, so it's 12.5A. This is going to be 50A. This is going to be 12.5A. So total is going to be 75A, right? Well, for we know it's going to be 90. That's why we calculate them in A. It's easier for us to calculate next. Rather than writing 5.5, I encourage to use 12.5A, 12.5A. That's why it's only 2 marks. Very simple. And that's it. Ready for the next question?
Ready, sir. Ready anytime.
Okay. A particle moving in straight line starts from the rest at point A, comes in tangent at rest at point B. Okay. In this case here, we know at point A, distance of A is going to be, instantaneously to rest at point B. So the velocity at B is going to be 0. From rest at point A means velocity at A is going to be 0. We have the acceleration. A is 6t power half minus t. Now, our information is about acceleration, but the question is about the velocity. Here we are going to use that the velocity is integration of A dt. Acceleration velocity and distance. Going up, we are going to differentiate. Going down, we are going to integrate. So a to the velocity, we are going to integrate. Okay, so we have them here. That's going to be integration of 6t power half minus 2t dt. It's going to be 6 over half plus 1, t to the power of half plus 1, minus 2, okay, to the power of 1 plus 1, t to the power of 1 plus 1, plus a constant. Okay, this is going to be the formula for the velocity. So it's going to be 4t power 3 over 2 minus t square plus c. That's the velocity of v. Okay, up until this, okay, we know two things. First, we know that when t equals 0, position A, then v equals 0. It means that the c must be 0. So v is 4t power 3 over 2 minus t square. That's it.
How can you know that the t is 0 and v is 0? Like such.
This one here, they say from rest at point A. So rest means the velocity is 0. Time A is 0, velocity A is 0. In position A, the time is just started, just start. So the time at position A is 0, and the velocity is also 0 because at rest. Now, if we put the number there, 0 is 4 times 0 square, 0 3 over 2, minus 0 square plus c. We found that the c has to be 0. Okay. Now, we know the formula now. The formula says that v is 4t per power 3 over 2 minus t squared. Now, the value of t at point B. At point B, the t at B, we don't know, but the velocity at B is also 0. Okay, so let's put them here. 0 is 4t power 3 over 2 minus t squared. I'm going to write them here. 4t power 3 over 2 minus t squared is going to be 0. You can divide this by t to the power of 3. Divide this by t to the power of 3 over 2. So we have 4 minus t power half is 0. So t is 16.
Wait, I'm still not getting it. Like, how can you explain?
Okay. This is t power 1.5. Okay, and t power 2. I'm dividing them by t power 1.5. T power 3 over 2. If we divide them, the 4t simply become 4. The t power 2 become t power half.
Why are we dividing them?
When we divide, we subtract the power, right?
No,
If
why
we
are
have
you
t
dividing
power,
them? Why are we dividing in the first place?
oh, so that we can calculate the t.
Okay.
If we have this, you can find t, right?
Oh yeah. Okay, great. Yeah. My bad.
Okay. So this is t at b. T at b is 16. Okay. Okay. Can I erase this then?
Sure then. Sure thing. after after this, like, is it like the one where like the splitting thing? Because I think I need a review on that one as well. Like, I still remember, but then it's like very foggy. Like the one that like you have to split the angles and such. You get what I mean?
Okay. Find the distance traveled from A to the point at which the accelerations of the particle is again 0. Okay. So here, we need to find out the distance now. Here, we need to find the equation for distance. The velocity is 4t3/2 minus t squared. This is the velocity. They're asking the distance. So the S is integral of Vt dt. Integral of, integral of V dt, my bad. Integral of V dt. Okay, that's going to be integral of 4t⁻3/2 minus t squared dt. Okay. How do we calculate the integration? That's going to be 4/3/2 plus 1 t to the power of 3/2 plus 1 minus 1/2 plus 1 t/2 plus 1 plus c. That's going to be the formula for the distance. So 4 divided by 5/2. What's that? That's going to be t to the power of 2.5 minus 1/3 t to the power of 3. This is going to be 4 divided by 2.5. It's going to be 1.6 plus c. Okay. So this is the value for the formula of S. What is the value of C here? Okay. At A, when t equals 0, S equals 0. If we put this number into this equation, we have the C equals 0. So the formula of S is 1.6 t to the power of 2.5 minus 1/3 t cubed at S. Okay. All we need to do now is, okay, acceleration 0 again. What's the acceleration of the formula? The acceleration is given at here 6t power half minus 2t. This value must be 0, and we are to calculate what is the value of t when acceleration is again 0. Now, how do we calculate this? Many ways we can do that. Let's say we divide this by 2. We have 3t squared minus 2 is 0, right? If you put t on the other side, we have 3t half is going to be t. Try to square it. You have 9t is t squared, so t is 9. Okay, so from here,
sorry, wait.
yes,
So that means 60
power half,
60 power half minus 2t, right? So that means you simplify it
yes,
into 3t power half minus t, and then you just
yes,
put it there, 3t, put it the other side. So 3t power half equals to t, which means that after
you can square them.
simplification, oh, you square them?
No, we square them left and right. So t power half become just t.
Okay.
So put the t of 9 into the equation. S is going to be 1.6 times 9 to the power of 2.5 minus 1 over 3 times 9 cubed. That's going to be 1.6 times 243 minus 81. Oh, sorry, 243. My bad.
Also, you use the t, the value of t. Oh, okay, I got it.
Minus 243. Okay, so you just calculate the number there. It's 0.6 times 243. Okay.
Okay.
This. Okay, I think that will be it for now, Brandon. It's 5 o'clock. I think I'm going to go another activity.
Yeah, that's okay, sir. Can you do you have like okay? So that means on Wednesday, like, are you able?
Il est
Or
17 heures.
or Thursday?
Let's see. Okay, my schedule is pretty fluid lately. Sometimes I get extra tasks. Sometimes I